All right, so the last thing that we're going to take a look at is how we can identify different families of organic compounds. In order to do that, we're going to take a look at what are known as functional groups in organic compounds. So these, you can think of these functional groups as sort of like the fingerprint that allows us to identify what something is, right? Sort of categorize it based on what's present. So what a functional group is, it's either type of bond or a collection of atoms that give particular properties to a compound. Okay, so we'll take a look at these, kind of go through them here. There's several of them, and then you get an exercise in this in lab to try to practice this as well. So let's take a look at the first one. So the first one we mentioned a couple of times already. So your alkenes, right? These that's the functional group that we're naming it, and these, as we already have seen, contain the carbon to carbon double bond. Okay, so the remaining bonds can be to whatever else, but as long as you have this carbon to carbon double bond there, that means that that belongs to the alkene family. Okay, we've also saw the alkynes. Okay, the alkynes contain the carbon to carbon triple bond. Okay, so if you see that triple bond in a structure, right away you know that it belongs to the alkyne and it will undergo similar reactions, have similar properties like other alkynes do. The next category are known as alcohols. And when you hear the term alcohol, you normally think of a particular alcohol, but the word alcohol actually is a family of organic compounds, and they are characterized by containing or by having an OH functional group, and this is known as a hydroxyl functional group. And that OH is connected to something else. The rest of the molecule that usually has a bunch of carbons, we're going to refer to that as R. R here just means the rest of, or the remainder of the molecule. And it's usually it contains a carbon containing, or contains carbon. And it could be a single carbon with a bunch of H's attached, or it could be 50 carbon. It doesn't matter. It's just the rest of it. The key thing here that we're looking at is this OH, right? That hydroxyl group tells us that it's an alcohol. Another functional group we'll see is known as the aldehydes. Okay, and aldehydes contain this functional group. So you'll see a C connected to an O with a double bond and then an H on the other side. And then that remaining fourth bond to carbon is to the rest of it. That's just the R group. The key thing here is you see that carbon with a double bond to an O and then a single bond to an H on that same carbon. Something that looks very similar to an aldehyde is called a ketone. Okay, and a ketone is going to contain the following. We'll see that C double bond O again, but now instead of being connected to an H on one side, it's connected to two carbons on either side of it. Right, so this looks very similar, but there's a small difference, but it's a big difference in terms of the family that it belongs to. So let's just specify this here, carbons on either side of that C double bond O, whereas in the aldehyde, there's an H, at least one H connected to the C double bond O. There's another functional group that looks very similar, and it's called a carboxylic acid. Carboxylic acid will contain what's known as the carboxyl group, and that is sort of a combination of the C double bond O and that OH, which is the hydroxyl we saw before. So when this hydroxyl now is connected to a C double bond O, that entire thing is called the carboxyl group, and that tells you have a carboxylic acid. So this is a carboxyl group. A couple more we'll see here. One that looks very similar to a carboxylic acid, and it's called an ester. So if you have a C double bond O, and then an O on one side, and now instead of being connected to an H like in the carboxyl group, if that's connected to a carbon, you have a carbon on the other side, that then is what an ester is. So C double bond O, that's your ester. And then the last two, we'll take a look at the ones that contain nitrogens. There are just two that contain nitrogens, and these only belong, there's only essentially two options here when you see a nitrogen in a organic compound. So the first one is called an amine, and amine is going to have an N connected to an R group, and then we have two H's attached to it. So that, that tells us it's an amine. Let me see if I can erase that line. So that's your amine functional group. And then if you see instead that nitrogen now connected to a C double bond O, well then now we know that it's not an amine. Now it's the other option, which would be the amide or the amide, however you want to pronounce it. That N there can also be connected to R groups on the other side. Okay, so these are the functional groups that you're going to encounter. We're not going to talk a whole lot about these, but you should be aware of the fact that, yeah, there are many different families of organic compounds, and some of these are more common than others. Okay, we've talked in a little bit of detail about the hydrocarbons, so things like your alkanes, your alkenes, and your alkynes. We mentioned briefly about your alcohols. So for example, take a look at a few of these. So something like methanol. Okay, methanol would be a CH3 connected to an OH. That's your structural formula, or just CH3 OH. Or even ethanol, which is the alcohol you find in alcoholic beverages. This has two carbons connected to each other, and then the OH is connected to one of them. All right, so we have a C and three H's. We have a C and two H's. Then we have an OH. So these are examples of alcohols. Methanol, ethanol, propanol, etc. Have that hydroxyl, that OH group. Aldehydes, so we take a look at the simplest aldehydes of something that is going to look like this. So one carbon aldehyde, this is this has a systematic name, but the more common name for this is formaldehyde. That's used as a preservative for biological specimen. The systematic name for this is methanal. Ketones, also very common. So if you think of ketone, that looks like this. So we have a C double bond O between two carbons on either side, and we're just sticking our H's there. Well, this is called propanone, more commonly known as acetone, nail polish remover, etc. Carboxylic acids, again, give you an example. If I have a two carbon carboxylic acid, so there's my C double bond O connected to the OH. If that is now connected to another carbon, and then I give that carbon enough H's to make it happy, I have a two carbon carboxylic acid. This is known as ethanoic acid, or sometimes called acetic acid, or more commonly, you know this as vinegar. Right? Vinegar is just a dilute solution of ethanoic acid. Esters, also common things. So if I have my C double bond O connected to the O, and let's say now on either side of this, I have just a couple of carbons. So let's say I have two carbons on this side connected to H's, and then another carbon on the other side connected to H's, what I end up with is a molecule. So again here, it doesn't really matter what's on the, what else is connected to the functional group. It's really the functional group itself. That's the most important thing, right? So this part here makes it an ester. Whatever else is connected really is irrelevant. This is known as ethyl acetate. And this is also found in nail polish removers, for example, right? So if you can imagine or think about that smell of nail polish remover, it's either due to the acetone or the ethyl acetate that's in there. Amines also have a, so by the way, esters usually tend to have a very, let's say, a pleasing or nice aromas associated with them, smells. Carboxylic acids tend to smell a little, on the other side, they tend to be a little bit more pungent. So if you think about vinegar, for example, very distinctive smell associated with it. Ketones, aldehydes, alcohols tend to have just like a chemically smell, for lack of a better word. Amines, these actually tend to smell like ammonia. And if you can think about like a sort of a fishy smell, that's usually what an amine smells like. And then your amides are essentially amines reacting with other functional groups, and you find these in things like proteins. Okay, so the amide functional group actually is the link that connects different parts of proteins together. You also find them in other places as well. So, you know, proteins, you find those in your skin, hair, nails, for example. Let me back up a second here. We looked at, you know, an example of an ester like ethyl acetate. You don't have to worry about the name, by the way. That's just the name of it. Fairly small one, but you also find esters in things like polyesters. So a polyester is just a polymer, a really large molecule that has many of these ester links that connect different parts of it together. Right? Polyester is commonly used in clothing, for example. And then your proteins also contain many of these amide links. These are polyamides. That are also very common. Obviously, you find them in biological systems and skin, hair, nails, for example. You'll find them in things like, you know, synthetically made substances. So natural places, but you also find them in things. So nylon, for example, is an example of a polyamide that's synthetic. It's made up of, it's a huge molecule made up of repeating amide links that keeps it together. So my point here is that you have organic compounds that contain these different functional groups, and they give these functional groups, whether they are collections of atoms or different types of bonds, they give different characteristics, different properties to a molecule that then, you know, kind of determines what it's used for.